Creating a sustainable concrete replacement. Nima, Rahbar and Suzanne Scarlata, researchers at Worcester Polytechnic Institute, WPI, have received $692,386 from the National Science Foundation (NSF) to enhance and develop new functions for their Enzymatic Construction Material (ECM), a living low-cost negative-emission building material they developed to address one of the biggest contributors to climate change, concrete, by providing a pathway to repair or even replace traditional concrete through a company called Enzymatic, Inc. Rahbar and Scarlata have already made their findings available for commercial usage. The new financing will also enable them to examine new applications for ECM, such as fixing chips in various types of glass, including windshields, cell phone screens, and eyeglass lenses. Create a program to teach impoverished girls from different backgrounds in Worcester and Africa about engineering and building, the necessity, the science, and the procedure for ECM. 4.1 billion tons of cement were produced globally between 1995 and 2020, making it the second most extensively utilized substance after water, according to Statista. Rahbar and Scarlata intend to utilize the new funds to improve and optimize ECM and the procedures to manufacture it, as well as expand its application to other materials, in addition to their efforts to assist alleviate the significant climate change consequences caused by concrete. Chemical reactions are sped up by biological enzymes, which act as catalysts. All living cells have the carbonic anhydrase enzyme, which is used in the production of ECM due to its extraordinary capacity to react with C2 and quickly remove the greenhouse gas from the atmosphere. Crystals of calcium carbonate, the primary component of ECM, are produced by this process. In order to hold the ECM together during its first stages, similar to how scaffolding does during building construction, a sand slurry and polymer are also added. ECM can heal itself through this process, repairing any cracks or other flaws that may appear over time while maintaining its strength through as many as 6 self-healing cycles. The study group discovered after thorough testing and experimentation that ECM has excellent compression strength, rivaling regular mortar, making it strong enough to be employed as compressive elements in the construction of buildings. In addition, it can be created rapidly, unlike the 28 days required to cure concrete, and it does not require baking at high temperatures like a conventional brick does. Due to the small amount of enzymes, ECM can also be made inexpensively. The researchers will be able to streamline the procedures so that EMC can leave the lab and get at building sites more quickly thanks to the new NSF funding. Glass that has been broken or cracked could be repaired using a new channel for the substance. Scarlata claims that her children's unintentional dropping and breaking of their cell phones provided her with the inspiration, which made her wish to find a means to fix, as opposed to replace, the phone's glass screens. Scarlata and Rahbar don't yet have any information on the viability of using ECM to mend glass, but they think it is feasible. According to Scarlata, this method of glass repair would save a lot of time, energy, and trash. It's a dream for now, but science progresses via dreams. Rahbar continues what it means for females and why the building sector should care. The grant will also enable Rahbar and Scarlata to create a program to inspire and educate underrepresented and disadvantaged girls about engineering and construction, an industry with a significant gender gap. According to OSHA, only 9% of construction workers in this country are female. This program will be based on Rahbar and Scarlata's lab work on ECM. The researchers intend to collaborate with Worcester-based groups, such as the Area's Girls Inc. chapter, to develop summer and after-school programs where girls will design a 6-inch model building, create a mold for it using 3D printing, then construct the structure out of ECM. Along with hosting visiting graduate students at WPI, Rahbar and Scarlata are working with the African University of Science and Technology to offer additional summer programs for this group.